Welcome back, GED scholars and math warriors, to another episode in our Math Wars, the trilogy awakens. And we already looked at episode 1, the decimal point. So if you missed that, please make sure you review that information. Make sure you also visit gedtalk.com/resources for that free worksheet so you can practice the skills that you are learning. In episode 2, the fraction strikes back, we're going to look at the fraction, and we already looked at the decimal, as I mentioned. And the decimal and the fraction, folks, they can represent the same value. The number will look different, obviously, but the value will be the same. And as I mentioned in episode 1, the reason why we're looking at the fraction and decimal and we're solving these problems without our calculator is because 12% of the exam, of the math exam, which is around 5 to 6 questions, you will be prohibited from using your calculator, which means you got to do it old school style. They're going to give you a whiteboard, or they might even give you paper. I don't know what state you're taking your exam in, but they're going to give you some type of tool to be able to use as scratch paper. And that's intended for you to definitely use during the section where you're not allowed to use your calculator. So in episode 2, the fraction strikes back. We are going to look at fractions. We're going to look at operations like addition, subtraction, multiplication, and division. So get ready, folks. Let's get into this episode. So let's start off with the basics. And as you can see on the screen, we have the setup of the good old fraction, the type that you would see. There would be a number on the top, and then there would be a line, and then there would be another number. So we just want to go ahead and name the numbers that you'll see on top and on bottom. So the top number is considered the numerator, and the numerator is how many parts you're working with. Versus looking down at the bottom, we see denominator. The denominator is how many equal parts are in a whole group. And so both numerator and denominator are called the terms of a fraction. When we look at this visual on the right, which kind of looks like a pizza somewhat, but it's only a pizza with marinara sauce. However, you'll notice that 3 of those slices have the orange pepperoni. So what we would be able to do then is to say out of this whole group that has a total of 8 slices, so I'm going to do 8 down here, 3 of those slices have these weird looking pepperonis. So then we have 3 as our numerator and 8 as our denominator. Why? Because 3 represents how many parts I'm working with. Only 3 have the pepperoni. How many are equal parts are in this whole group, in this circle? There are 8 equal parts. So therefore, the fraction is 3/8. And this fraction that we have, 3/8, is called a proper fraction, which means that this value is less than 1. The fraction, the value is less than 1. And in a proper fraction, our numerator is smaller than the denominator. Most fractions that you see are in the proper fraction form. However, there are also 2 other types of fractions, and one is not even called a fraction. It's called the mixed number, and that's what we have right here on the screen where it says 1.5. The 1 is a whole number. It's large. It's by itself. And then when we look at the visuals, we notice, well, that's true. One of the circles is completely blue, which this one, the big one, is representing. And in the second circle, we see that only half of it is blue. Therefore, we have that fraction 1/2. So 1.5 is our mixed number, and the value is greater than 1. Well, from this mixed number, and actually from what it's about to become, an improper fraction, you can go back and forth. And on the exam, they might ask you to do that. So let me show you what that means. So I have, like I said, a mixed number, 1.5. I can turn this into an improper fraction, and an improper fraction is equal to or greater than 1. And the way I'm going to do that is I'm going to do denominator 2, and I'm going to multiply it by the whole number 1. So 2 times 1, and then I'm going to add the numerator value. So 2 times 1 is 2, plus 1 will give me 3, and that's going to be my numerator. And then my denominator is 2, so I'm going to just plant a 2 right there. So this is your improper fraction, folks. This is going to be your mixed number. And you can go back and forth with how you set up these fractions when it comes to completing any of the operations. Especially when you're not allowed to use your calculator, you'll notice that having an improper fraction form is a lot easier to work with when it comes to subtraction. And we'll go ahead and take a look at an example in a moment. If you're wondering, okay, well, if I have an improper fraction, how do I get it back to the mixed number form? Well, folks, do some good old division. We're going to do 3 divided by 2. How many times can 2 go into 3? Once. Okay. If 2 goes into 3 once, 3 minus 2 is going to be what? 1. So then I have remaining 1 over 2. So before we jump into learning and completing different operations with fractions, I want to make sure that you know how to reduce or raise a fraction. So understand that on the math exam, all of the answers that are in a fraction form will be in the lowest terms. And that's when you reduce fractions. So say, for example, you do some math and you get the answer 10 over 15. Well, you can reduce 10 over 15 because there is a number that goes into 10 and goes into 15 equally. Do you know what that number is? If you guessed 5, you're absolutely correct. So whatever you do to the top, which is going to be divide by 5, I have to do to the bottom. It's kind of like algebra. Remember, with algebra, whatever you did on one side of the equal sign, you have to do to the other side. Same thing with fractions. Whatever happens to the top has to happen to bottom and vice versa. So 10 divided by 5 is going to give me 2. And then 15 divided by 5 is going to give me 3. So 10 over 15 is the same value as 2 over 3, except 2 over 3 is in the reduced form of this fraction. And notice that we were dividing, folks. In addition to being able to reduce a fraction, you want to make sure you know how to raise a fraction. So raising a fraction is multiplying both terms by the same number. And say, for example, you have 3 over 4, but you're going to add it to another number that doesn't have 4 as the denominator. And we're going to look at an example in a moment. Well, you're going to have to raise this fraction, 3 over 4, to get to that denominator that you're trying to get to. And say, for example, you want to make sure that your fraction denominator is 12. Well, what did you multiply 4 by to get to 12? You multiplied by 3. So I'm going to write times 3 down here. Whatever I do to the bottom, I'm going to do to the top. So 3 times 3 will give me 9. So I raised this fraction 3 over 4 to 9 over 12. So let's look at the first 2 operations when we deal with fractions, which is addition and subtraction. And notice the note down here, it says must be like fractions, which means the denominators have to be the same. If you want to add, subtract 2 fractions, the bottom number has to be the same. So this top one, we have 3 over 10 plus 5 over 10. So that is going to give me, I'm going to just go add right across. What's 3 plus 5? I get 8. And then I don't do 10 plus 10. I just keep the denominator as 10. And if you're like, wait, I can reduce this fraction 8 over 10, you're right. What number goes into both 8 and the 10 equally? 2. So I'm going to divide by 2 and I'm going to divide by 2. So then I get 4 over 5. And that's the answer for this first one. The next one is subtraction. Same concept. You're only going to subtract the numerator. So 9 minus 5 is going to give me 4, and then the 10 will stay the same. 4 over 10 is not in the lowest terms, so what number goes into the 4 and the 10 equally? Yeah, 2 does. So let's divide by 2 on the top, and we're going to divide by 2 at the bottom. 4 divided by 2 is 2. 10 divided by 2 is 5. So our answer is 2 over 5. So let's go ahead and look at the example on the right. Notice that the denominators, we have 6 right here in the first fraction, but we have 4 over here in the second fraction. Well, if we want to add these, we need to make sure their denominators are the same. So what is the smallest or the lowest value number that both 6 and 4 go into? 12. Okay, well, if I want the denominator to be 12 here, and I want the denominator to be 12 here, how did I get from 6 to 12? I multiplied by 2. So whatever I do to the bottom, I have to do to the top. So what's 5 times 2? We get 10. How did I get from 4 to 12? I multiplied by 3. So whatever you do at the bottom, you got to do at the top. 3 times 1 is 3. Now my denominators are the same. I have 12 and I have 12. Now I can go ahead and add across. 10 plus 3 will give me 13. And then I bring over the 12. What is this called, folks? Do you remember? Right. It's an improper fraction. The numerator is greater than the denominator. You look at your answer choices and say, this isn't a choice, but you do see mixed numbers. Try converting this to a mixed number and see what you get. And let's do this right now. How many times can 12 go into 13? once. So if 12 goes into 13 once and we had 13 minus 12, we have a remainder of 1 over 12. So let's look at another subtraction example. So we have 7 over 9 minus 1 over 2. And we know that our denominators are not the same, so we need to make sure that we get these, the 9 and the 2, to a value that both can go into evenly. So I know 9 times 2 is 18, and that's the lowest term or the lowest valued number that we can use for our denominator. So I know that I want the denominator to be 18 on both sides for both fractions. Well, how did I get from 9 to 18? I multiplied by 2. So whatever you do to the bottom, you got to do to the top and vice versa. So 7 times 2 is going to give me 14. So moving over to the next fraction, how did I get from 2 to 18? Well, I multiplied by 9. So if I multiply by 9 at the bottom, I have to do the same thing at the top. 9 times 1 will give me 9. So now we have the same denominator. Let's go ahead and subtract, and we're going to subtract across the line. So 14 minus 9 is going to give me 5 over 18. And that's our answer, folks. So let's go ahead and look at an example of adding or subtracting. And for this example, it's obviously subtracting mixed numbers. And so we have the mixed number 4 and 1/16 minus 1 and 3/8. And we know right off the bat that we need to make sure they have the same denominator, which they don't. So we need to tackle that aspect of it. And I want us to do that first. The method we're going to use is called regrouping. And if we get through the end of this and you're like, wow, how am I going to remember that? Stay put, folks, because I'm going to also share how you can do the same thing going about it with using improper fractions. It takes a lot more steps, but it might be the best way for you. But let's try subtracting. We see our mixed numbers and we're going to regroup. But like I said, we're first going to get the denominators the same. Well, I have 16 on the left, and I know 8 can go into 16 two times. So when I take care of that, I then have 1. And then if I did 8 times 2 to get 16, I have to do that to the denominator. So 3 times 2 will give me 6, and then I have 16 below. So now I have 4 and 1/16 minus 1 and 6/16. And if you're like, how is this going to happen if we have a 1 up here and then we have a 6 over here? And we don't want to put this entire mixed number first because then we're doing the whole number 1 minus 4. So this whole regrouping is going to take place now. So what I'm going to do is I'm going to come over here to the 4 and 1/16, and let's get rid of that circle around the 1. So to regroup, I'm going to go to the 4 and I'm going to say, hey, 4. And obviously, I'm not going to talk to the 4, but I'm thinking out loud for you. But I'm going to say, 4, I need 1 from you. I need to borrow 1, which will make you a 3 because I've borrowed 1 from you. But when I borrow this 1, I need you to give it to me in fraction form. So when it shared that 1 in fraction form, it didn't give it over as a 1. It gave it over as a 16/16 because that's 1. And so what I'm going to do is I'm going to take that 16 over 16 and I'm going to add 1 over 16, which was already there. So now I have 3/17 over 16. Now I'm able to go ahead and take care of this problem. I'm going to draw a little wall for us. So instead of 4 and 1/16, I have 3 and 17/16 minus 1 and 6/16. Now, since they have the same denominator, I can go ahead and take care of this. So let's start with the whole numbers. So 3 minus 1 will give us 2. 17 minus 6 will give us 11. And then the denominator is 16. Can we reduce this fraction any more than what we have here? Nope, it's good the way it is. 11 over 16 is as low as it can get. So our answer, folks, is 2 and 11/16. We are going to subtract the mixed numbers, but instead of regrouping the first one, we are going to convert both of them into improper fractions. So let's go ahead and get started with converting these mixed numbers into improper fractions. So I'm going to multiply the denominator with the whole number, and then I will add the numerator. So 16 times 4. And if you're like right there, I'm stuck because I would need my calculator. Well, folks, you know how to add. So 16 times 4 is 16 plus 16 plus 16 plus 16. So 6 plus 6 is 12. 12 plus 6 is 18. 18 plus 6 is 24. So I'm going to drop off the 4, carry the 2. Then I have 2, 3, 4, 5, 6. So I have 64 plus the 1 will give me 65. And let's make this look like a 4. So I have 65 over 16. Well, let's do the same thing over here with the fraction or the mixed number on the right. But folks, what do we notice? We notice that this denominator is not the same as the one on the left. And I know that 8 can go into 16. So I want to use 16 as my denominator. Okay, so we know we're going to multiply by 2 on the denominator. So I'm going to have to do that with the numerator. So now I have 1, and then I have 6 over 16. So now let's convert this to an improper fraction. 16 times 1 is 16 plus 6 is 22. So I have 22 over 16. Now we're going to subtract. So I have 65 minus 22. So 5 minus 2, let's draw the layout. 5 minus 2 will give me 3. 6 minus 2 will give me 4. And then I keep the denominator as 16. So we have 43 over 16. And if you're like, I'm looking at my answer choices, I don't see any improper fractions. They're all mixed numbers. That's just code for you need to take this improper fraction, this answer, and convert it back to a mixed number. So let's think about how many times does 16 go into 43. Okay, so if I have 16, 16, 16, I know this is 32. Well, 32 plus another 16, 2 plus 6 is 8, 3 plus 1 is 4. Nope, 48 is too big. So I know that 16 can go into 43 2 times. But, okay, so it goes into 43 2 times. So I would do 43 minus 32, because that's 16 times 2. 8 minus 2 will give me 1. 4 minus 3 will give me 1. So I have 11. Remainder 11 over 16. And that's the same exact answer we got when we regrouped, folks. So just know if you are asked to subtract mixed numbers, you can either regroup or you can convert to improper fraction and take care of it this way. Next up is multiplication, and multiplication is definitely easier for some because you don't need to worry about the denominators being the same. All you're going to do is you're going to multiply across the numerator and across the denominator, and then you'll reduce your fraction. As I mentioned earlier, all of the fraction answer choices will be in the reduced form, unless the question is, hey, this is a reduced fraction, find the equivalent. That might be a little bit larger, or they might give you the reduced fraction and your answer choices. They'll ask you which one of the following is the raised form of this fraction. So you just want to be mindful of it. But when they're asking you to multiply, they should be sharing all of the answers in the reduced fraction form. So let's go ahead and multiply across the lines. So 7 times 1 is going to give me 7. 8 times 2 is going to give me 16. Is this in the reduced fraction form? Absolutely. 7 over 16 cannot be reduced anymore. Okay, well, what if you get a mixed number? That's okay, folks, because you know how to convert this mixed number into an improper fraction, which is what we're going to do right now. So 4 times 3 is going to give me 12, plus 3 is going to give me 15. So 15 over 4 times 1 over 3. 15 times 1 is 15, and then 4 times 3 is 12. So we have an improper fraction, and if we need to convert it back over to a mixed number, that's easy. So we have 15 over 12. Well, how many times does 12 go into 15? It'll go in there once. So if we have 12 into 15 once, if we subtract 15 minus 12, we get a remainder of 3 over 12. Can we reduce this fraction? Absolutely. 3 over 12 can be reduced because 3 goes into 3 once. 3 goes into 12 4 times. So then our answer is 1 1/4. So last operation we are going to look at with fractions is division. So the problem reads, Mark has an 8-pound bag of candy. He wants to fill smaller half-pound bags. Okay, so we have 8 divided by 1/2. And the note after the problem says invert the divisor and switch the sign. And if you're like, what is the divisor? So the problem reads 8 divided by. So what is it divided by? It's divided by this 1/2. This 1/2 is your divisor. It says invert the divisor, which we know is the fraction, the 1/2, and then switch the sign. So I have 8, and if you're like, well, 8 isn't a fraction, this is going to make it really hard for me. When you see a whole number by itself, it's resting over a 1. 8 is equal to 8 over 1. So we're going to do 8 over 1. I'm going to switch the sign, so not division, but multiplication, and invert, which means flip it. So now I'm going to flip my fraction, and I'm going to do 2 over 1. Okay, awesome. I learned how to multiply, just go across the line. So 8 times 2 is 16. The denominators, 1 times 1 is 1, and 16 divided by 1, folks, is 16. That is your answer. Thanks for watching episode 2, The Fraction Strikes Back. Please make sure you visit gedtalk.com/resources to download the free worksheets. And as I've mentioned, learning these skills is one thing, but it's really important for you to practice the skill so you remember how to complete it when it comes to test date. You know what you're doing, folks. You've got this. Keep your head up.